Okay, number 2. Holy crap, look at this problem. It's long, right? You have a piston cylinder device, contains 5 liters of saturated liquid at constant pressure. Water is stirred by a paddle wheel while a current of 8 amps flows through 45 minutes through a resistor placed in the water. If 1/2 of the liquid is evaporated during this constant pressure process, and the paddle wheel work amounts to 400 kilojoules, determine the voltage of the source. Whew. That is a tongue twister, right? What's that? So we know it's isobaric. It could be, right? Does it say it's insulated? Yeah. So what does that mean? It doesn't mean the temperature could change. It means what? It's insulated.
No energy is constant by 0.
What energy is constant? Not delta U. Q. Q is 0. There's no heat transfer. The temperature could change, right? Because if you are stirring something, but it's insulated, you're stirring it inside, the internal energy could change. Okay? All right. Yep. What other keywords? Paddle wheel. Yep. That's so we give that.
So
That's 400 kilojoules.
If there's a resistor, would it be like include electrical work?
Yep. So there's electric work because we have a resistor. And that's 8 amps times the voltage, which you're trying to look for. Okay. What are the keywords? Saturated liquid is a big keyword, right?
Yep.
We already know the pressure. What do we automatically know about V? Little v. What's on the table? It's VF. We already know it's VF, saturated liquid. If I said saturated vapor, it would be VG. Okay. See how last chapter, now you use it with this chapter? What else? So 1/2 the liquid is evaporated. So which way are we going on the PV diagram?
We're going to the right.
To the right. Yeah, you're right. Okay. Yep.
So you
We're going towards the
0.
G.
Moving quality like 0.5 from 0.
Well, we don't. Quality would be 0, and then half. Yeah,
And
quality is
about
0.5. Then you use the what equations to find your specific volume at state 2. You have to use the quality equation that I gave you. That interpolation one. Remember? Okay. Questions so far? China, is it sort of making sense? Where do you start with? Start with the first law. Right, the first law right down. Delta U equals Q in minus Q out plus work in minus work out. And what are you going to cancel automatically? Q. Q goes away. Then you got to figure out, okay, how do I find delta U and what are my work terms? Work is always in. If you're stirring it, it's in. If it's electric, it's in. Okay. So weird how this does it.
I've got a quick question.
Yep.
I'm trying to find the voltage given a current.
Yep.
How do we work what we know in ohms law?
Okay, what is, we got 1 minute to talk about this. Tell me electric power.
Current times the voltage.
Yep. Tell me electric energy. Well, it's W dot E times. Time. Delta T. So that has a unit of joule. What is the unit of the stirred? Kilojoules, which is joule. Okay. That's why they gave you the 45 minutes. Because you have to multiply by time to figure out your actual work developed by that resistor. Okay? So let's look at number 1. We'll go through them all, and then we'll maybe pick one that we want to look at, okay? So number 1, a piston cylinder device initially contains 0.07 meter cubed of nitrogen at 130 kilopascals and 120 degrees C. The nitrogen is now expanded polytropically to a state of 100 kilopascals and 100 degrees C. Determine the boundary work in this process. So let's just kind of nitpick this. Key words. Polytropic, piston cylinder,
Nitrogen gas.
nitrogen. So right there, you automatically know that there's a boundary work equation for polytropic. We know there's nitrogen, so you can write all the givens that come to your mind for nitrogen. Go back to the table. You probably might need R, CV, CP, right? So I would write those three down. And you already know that initially you know your volume, which would be V1. You know P1 and you know T1. Okay? And if it says it's nitrogen, then it's definitely a gas. Okay?
Where do you write that stuff? Do you write that in like a properties thing, or can you just write that all in givens?
What's that?
Like nitrogen's properties.
You can write it in the givens, or there is an option if you wanted to, just write properties as a heading, like next to your givens, and write those values down for nitrogen. Yep. Gravity, densities.
Short stuff.
Yep. Now, if you remember, we're in thermo now. The densities could change because we know that density is 1 over the specific volume, and we know specific volume changes. So yes, but if you know your states, you could do that too. Okay. We now know P2 and T2. What don't we know about the polytropic process? N. So you need to find N. And I'm not going to tell you how to find N because it's a little tricky. Okay, I want you to think about it first. But if we go back, what equation are you going to use? Oh, I need to plug this in. Where'd it go? Polytropic. I can tell you N is not going to be 1 or 0. We're going to use that one right there. Okay? But you have to set up the problem like that one to solve for N. Yes, you know what P1, V1 is, plug those in. You know what P2 and V2 is, and plug those in. Yep. But the N is only raised to the V, so you have to figure out how to do that. Yep. So I would set the problem up under your solution, label it polytropic process, write that, solve for N. Okay? Once you solve for N, you can just plug it in there and you're done. Okay? There is 2 ways you could solve for N. First way would be, you could actually do it mathematically. What's the other way?
Yes, you can ask you the answer.
Okay, there's 3 ways. You can ask me for the answer, but I won't tell you the answer. Okay. Guess. You could guess, so I guess there's 4 ways.
How many effective?
Can we make it 5 ways?
Tables and graphics. Okay, that's the way I would do this. Okay, would be make a column of N values and plot them and see when the left-hand side equals the right-hand side. So plot 2 lines, and wherever they intersected, that you can extrapolate the N. Right? You ever done that before? So let's call this. This is just how I would do it. Left-hand side.
Wait, I just solve it like without doing that.
Yeah.
Just solve the function.
Yep. So if you plotted left-hand side and right-hand side versus N, I don't know, you would get a point where they intersected. And that would be your N value. That's the way I would do all these problems. Okay, I don't know. I'd rather plot it and get it done with than have to worry about thinking about math, right? Because I'm not thinking anything when I plot. I'm just making a column of N's.
Just buy a fancy like calculator and solve that on that.
Yeah, but that's not good. I guess that's the 5th way. Yes.
If we were to do that, would you want us to show you our columns?
Yes.
You just want the chart?
Nope. You give me both, but it doesn't have to be like perfect heading, because this is kind of a side note that you did. That's fine.
How do you properly pick some values to throw in? Do you just pick a wide range?
Go from like 0 to 5, and if you find that they don't cross, expand your search. Yep. Yep. Yes.
So the question I have is, N can't be any negative value.
No. Yeah. Yep. It could be 0, 1, or anything greater. Yep. Yep.
So we're gonna have P1, V1, and P2
Say that again.
from the problem.
Yes. Yep. 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 But there is a way you can do it mathematically. Yes. Ooh, good questions.
Can you just do this in Excel and then like draw it in, or do you want us to print it off?
If you do it just in Excel, I mean, I'm fine if you just give me the plot. That's fine. Just give me the plot. Yep. It doesn't have to be headings. Just show me that you did it, because it's more of a side note. Yep.
Are you gonna tell us the mathematical way, or do we have to figure that out?
Try it. Try it. And then on Friday, if you've attempted it, I can help you. Correct? Yeah. Not as, yep. It's doable. It's not that bad. It's just got to remember some log rules. Yep. Okay. Wow. You guys are lively with questions. That's good.
Because it's not Monday, it's sort of Monday.
It's sort of Monday. Yeah.
We're refreshed.
That's good.